Use logarithmic differentiation with all properties of logarithms. Alright, in this video we're going to talk about that second situation where we're going to want to use logarithmic differentiation. And that second situation is we want to avoid using the product rules, the quotient rules, or a combination of both. And as we can see here, we have a combination of both. So, let's dive right in. So here we go, let's dive right in. So we want to use logarithmic differentiation to take the derivative of x cubed minus 1 to the fourth times the square root of 3x minus 1 all over x squared plus 4. Alright, so if you notice, we can't use any of our logarithmic properties here because there are no natural logs. So what we're going to do is we're going to take the natural log of both sides of this function. So we're going to have the natural log of f of x is equal to the natural log of this huge guy, x cubed minus 1 to the fourth times the square root of 3x minus 1 all over x squared plus 4. Alright, so now we have the natural log of both sides, so now we can use our logarithmic properties to pull it apart. So we're going to have the natural log of f of x is equal to the natural log of the quantity x cubed minus 1 to the fourth times the square root of 3x minus 1 minus the natural log of x squared plus 4. And now we can continue breaking this up. So we have the natural log of f of x is equal to the natural log of x cubed minus 1 to the fourth plus the natural log of the square root of 3x minus 1 minus the natural log of x squared plus 4. And then we can continue simplifying now, dealing with the exponents. So we're going to have the natural log of f of x is equal to, I can take this 4 and bring it to the front. So we're going to have 4 times the natural log of x cubed minus 1 plus, remember we can rewrite anything that has a square root as being to the 1/2 power, which we can also now bring to the front using that logarithm property. So 1/2 times the natural log of 3x minus 1 minus the natural log of x squared plus 4. So now all we have done so far is we've taken the natural log of both sides, and then we have applied the natural log properties to simplify our function down. We have not actually done any calculus yet, and we haven't taken the derivative yet. This has all been algebra, pre-calc 1 if you took it here. Now, next, we're going to take the derivative. And we need to take the derivative of both sides here. So looking on the left-hand side, we're going to have the derivative. We need to take the derivative of the natural log of f of x. And the derivative of natural log says we do 1 over the inside times the derivative of the inside. So in this case, the natural log of f of x is going to be 1 over f of x times f prime of x. And we'll come back to that later. Now we're going to take the derivative of the right-hand side. So again, that 4 is a coefficient, so that's going to stay alone, times, we said the derivative of the natural log is 1 over the inside, so 1 over x cubed minus 1, times the derivative of the inside, which is going to be 3x squared. Moving on to the second term, so plus 1/2, derivative of the natural log is 1 over the inside, which is 3x minus 1, and then times the derivative of the inside, which is 3. And then our last term minus 1 over the inside, which is x squared plus 4, times the derivative of the inside, which is 2x. Next, I'm just going to simplify as much as I can here. So 1 over f of x times f prime of x is going to be f prime of x all over f of x equals. And then 4 times 1 over x cubed minus 1 times 3x squared is going to be 12x squared all over x cubed minus 1 plus, let's see, 1/2 times 1 over 3x plus 1 times 3 will give us a 3 in the numerator, and then we need to multiply everything in the denominator by 2, giving us 6x minus 2, and then minus 2x all over x squared plus 4. Alright, great! So now we have taken the derivative. But if you look at the question doesn't explicitly say find the derivative. It says find f prime of x, which again, I know is the derivative. And all I'm trying to say with that statement is now we just need to get the f prime of x by itself, meaning we have to get rid of this pesky f of x. But that f of x is in the denominator. So if we would multiply both sides by f of x, the f of x in the denominator would cancel out with what we're multiplying by, giving us f prime of x by itself. So I've run out of room, so I do need to erase some of these earlier steps. So we're just going to erase some of the stuff up here. If you need it, you can always, rewind the video. That's the great thing about the video. Alright, so now that's erased, and now I'm just going to rewrite. So I'm now going to have f prime of x is equal to 12x squared all over x cubed minus 1 plus 3 over 6x minus 2 minus 2x all over x squared plus 4. And again, this whole thing was multiplied by f of x. So now you're probably telling yourself, great, we're done. We got f prime by itself. And yes, that is true. We did get f prime by itself, but we didn't simplify it because we still have this f of x here. Well, what do we know f of x is? Well, based on the original problem, f of x is this guy up here. So therefore, f prime of x is going to be equal to the quantity 12x squared all over x cubed minus 1 plus 3 over 6x minus 2 minus 2x over x squared plus 4 times our original function, which is the quantity x cubed minus 1 to the 4th times the square root of 3x minus 1 all over x squared plus 4. And while technically you could distribute this whole last expression into the other three terms, this is as far as I'm going to require you to simplify this here. That algebra is unnecessary. So therefore, that is your answer. Super long, super complicated, but it makes sense because this was a super long, super complicated function. So boom. Side note, if you were to solve this out using the product, the chain, and the quotient rule, you would get something equivalent to this, but it might not look the same. Which is fine. Doesn't mean you're wrong. It just means since we didn't solve it the same way and we didn't simplify it completely, you could have two separate answers that are the same. And you could always test them out by plugging in a random x value and seeing if you get the same numerical answer for the slope. Alright, that was one problem done. Let's move on to another one. So, similar thing here, f of x is equal to x times the square root of 2x plus 1 all over e to the x times sine cubed of x, and we want to find the derivative. So, same process here. We want to pull this apart using natural logarithms, but that's going to require us to have, natural logarithms. So we're going to take the natural log of both sides of our function. So the natural log of f of x is equal to the natural log of this whole guy, x times the square root of 2x plus 1 all over e to the x sine cubed of x. And then we can start pulling apart the right-hand side. So we're going to have the natural log, and I just wrote an f instead of a parentheses. Natural log of f of x is equal to the natural log of x times the square root of 2x plus 1 minus the natural log of e to the x sine cubed of x. And now we can pull apart both multiplications. So we're going to have the natural log of f of x equals the natural log of x plus the natural log. And instead of writing a square root, I'm just going to go ahead and write this as 2x plus 1 to the 1/2 power, because we know those are equivalent. And then minus, and remember, here's the part we need to be careful of. Remember, both of these terms, e to the x and sine cubed, are in the denominator. So that means it needs to be minus ln of e to the x, and then another minus the natural log of sine cubed of x. So be careful. That's where a lot of students get stuck, is they forget that second negative sign, that they're both in the denominator. Alright, so now we're going to take care of all of our exponents. So again, still the natural log of f of x is equal to the natural log of x plus 1/2 times the natural log of 2x plus 1 minus the natural log of e to the x minus 3 times the natural log of sine of x. Because remember, with sine of x and sine of x cubed, that is the exponent, so that would come to the front. Alright, so again, that has all been algebra. No calculus yet. We're about to take the derivative and do some calculus. So the derivative of natural log of f of x is going to be 1 over f of x, and then times the derivative of the inside using the chain rule, which is f prime of x. Let's see, the derivative of ln of x is just 1 over x, and then plus our 1/2 is our coefficient, times 1 over 2x plus 1, times the derivative of the inside, which is 2, minus. Now, with the derivative of the natural log of e to the x, you could take the derivative of the natural log of e to the x here and still get the same answer. However, let's take a look and let's notice here that natural log of e to the x are inverse functions, meaning the natural log and e are going to cancel out, leaving us with just x. So really, we can rewrite this term as just being x. Now, what's the derivative of x? Well, the derivative of x is just 1. And again, if you would take the derivative of natural log of e to the x like normal, you would still end up with 1. So even if you don't necessarily recognize that right away that they're inverse functions, you'll still get the correct answer, assuming you do the problem correctly. And then, finally, minus 3 times 1 over sine of x. And the derivative of sine of x is cosine of x. And now we can just simplify. So we're going to have f prime of x over f of x is equal to 1 over x plus, let's see, this 1/2 and 2 are going to cancel each other out, leaving us with 1 over 2x plus 1 minus 1 minus 3 cosine of x all over sine of x. And just like before, I've run out of room, so I'm going to have to do a little bit of racing up here. If you missed any of that, you can always go back and rewind the video. Wonderful thing about the video again. Alright, so we're going to be left with f prime of x over f of x, and that is going to equal 1 over x plus 1 over 2x plus 1 minus 1 minus 3 cotangent of x. And let's remember, the reason it's cotangent is because we have cosine over sine. Cosine over sine is equivalent to cotangent. So I just substituted that in there. All right, and then finally we need to get the f prime of x by itself, so we have to multiply both sides by f of x, where this f of x and that f of x cancel out, leaving us with f prime of x equals 1 over x plus 1 over 2x plus 1 minus 1 minus 3 cotangent of x. And remember, that is all times f of x. And f of x is just our original problem up here, so our final step is going to be to substitute that in. So we're left with quantity 1 over x plus 1 over 2x plus 1 minus 1 minus 3 cotangent of x. And that is going to be times x times the square root of 2x plus 1 all over e to the x sine cubed of x. So again, these problems are very time consuming. They are a lot of work, but using logarithmic differentiation, we save ourselves a lot of headache having to do a lot of chain rule, product rule, quotient rules. This one actually has a double product inside of a quotient with a couple of chain rules. So yes, this might appear to be longer and more difficult and more challenging, but it's actually simpler.